Next, we simulate the circuit when R equals 1 ohm. We'll still assume that the initial value of the capacitor voltage is 3 volts. Here we check the voltage of nodes 4 and 6. We click Simulate. Please look at the whole transient process of the circuit at this time. It's entirely different with underdamping and critical damping. We mark the grid so that everybody can see it clearly. First, we discuss a period during which the inductor current increases from 0 to the peak value, which is the same as the previous one. The capacitor voltage falls and the inductor current rises. It means that the energy of the capacitor supplies the inductor and the resistor. After this period and during the second period, the capacitor voltage continues to fall and the inductor current is declining. It means that the capacitor and the inductor supplies the power to the resistor. But the difference with previous ones is that the capacitor will be reversely charged when its voltage reaches 0. So this is the third period. In the third period, the inductor current is declining. The capacitor voltage is increasingly in the reverse direction. We know that the energy stored in the capacitor is 1/2 times C times 2 U squared. So the increase of the reverse voltage also means the capacitor is storing energy. During this period, the inductor not only supplies power to the resistor but also recharges the capacitor. Of course, the fourth period is similar to the first period. The capacitor voltage falls and the inductor voltage rises. That is to say, the capacitor supplies power to the inductor and the resistor. As we can see, there are energies exchanged between the capacitor and the inductor in the process of the underdamping. So the whole voltage and current has a sinusoidal oscillation waveform with attenuation. This feature is very important. In the subsequent lecture 58, we will discuss a lot of examples that the waveform of the capacitor voltage and the inductor current can be controlled by using underdamping oscillation effectively. In RLC serial connection to second order underdamping circuit, the inductor current reaches the maximum value first, then the value of the capacitor voltage becomes 0. Why? Because when the inductor current is with the maximum value, it has no voltage but has current. So the capacitor needs a voltage to make the whole circuit's KVL be balanced. But when the capacitor voltage is with the maximum value, or when the reverse voltage of the capacitor is with the maximum value, the inductor current must be 0. It means that the current flowing through the capacitor is 0 when its voltage is with the maximum value. So the inductor value current is 0. If you master these two different characteristics of RLC serial circuit, it will be very helpful.